In this video, we will show you how to do the measurements when we receive a sample. When we receive a sample of a specific component type, the first step that we do is creating a sample. What we mean by creating a sample means we are creating a logical group for a sample, an entry for a sample which belongs to a specific component type, and in that sample we are doing the measurement for all the joints in the component or in the sample. Let's say we are getting this component for measurement. So we get a normally companies measure a sample, one sample per day or one sample per shift or one sample per week. It totally depends on their customers defined requirement or process. Let's say we are measuring one sample per shift and we got a sample for this specific component type as we see in the screen in the morning shift or in the first shift, and we are going to measure that, and it is of type test comp which we created in the previous video. So coming back to the application window, when we receive a sample, first thing what we do is creating a sample. So if you look at the top right window, there are options to select the sample, select a joint, and the magnification. So what we do is, since I am creating a fresh sample, I am going to create a sample first. I click on this button, I will get a window to create a sample. If any samples are already created, it will list the samples. For creating a new sample, there's a plus button here, click on that. Here if you see, I am specifying the properties of my sample. My sample belongs to which component type? It is test comp which we created in the previous window. Which shift? Let's say I got it from shift A. Who is the welder name? These are optional. You can also specify from which robo line or which weld machine this came. You can maintain in the master a list of robo lines that you have, and you can specify from which robo line this sample came. So by default, this will create a default unique name. You can see the component name, the date, and the shift year. Or I can manually change the shift. So anybody looking at this sample knows that this sample belongs to the component test which is created on 11th May 2020 for shift A. So I'm clicking a button. Now I will select this. So this is sample I am going to measure. Now under the sample, if you remember the previous video, we have created only one joint, and we are planning to use that one joint template for measuring all these joints in this sample. You can also, as I said before, you can also create separate joint templates for each of these joints and select those corresponding joint template to measure that specific joint. It is totally depends on you. There are no hard rules on that. So right now, since we have only created one joint, if you click on that, it will list as job one. It's a generic name. Since I am create only one joint template for everybody, I just gave a generic name. I'm selecting that. Now I have to select the magnification. In a normal process, at this point, we select the magnification and we will be playing the camera. There is a button to play the camera. Here we are only showing the application, so we are not showing the microscope or camera part. But the normal process will be, when you click on the play camera button, it will open up a video showing the component that is placed under the microscope. By this time, you have already cut this component into smaller pieces, isolating each joint, and each joint you might have cut using an abrasive cutting machine to get the cross section. You might have finished the polishing to remove all the lines and other impurities on that. you might have etched it and placed it under the microscope. So we have 15, 20 joints here. You will have 20 pieces in front of you on your table. And you have placed the first joint. Let's say you have placed this joint WJ206 cross section under the microscope. So when I play the camera, this click the button and play the camera, the microscope will show a magnified image on this screen, a live video. If the component is small, you might have to increase the magnification. If the component is big, you may need to reduce the magnification. The idea is to get the screen, the video size, at least 50 to 60% should be the component, so that you can see both sheets. You can see the weld bead clearly and the boundaries and the isolated weld bead area correctly. Once you then you can do the focusing on the microscope, so that your image on that you see on this video will be clear and sharp. Once you have set the microscope correctly and selected the right magnification, you have to select the same magnification here. If you have selected 16x at the microscope, you have to select exactly 16x. If it is 20x, you have to select 20x here. Right now we have only calibrated for 2 magnifications. Typically, we will do the calibration for all magnifications. If you make a mistake here, for example, if you have selected 10x on the microscope, but I selected 16x on the software will work. It will capture the image. You can do the measurements, but your result will be incorrect. So this is very important, that whatever magnifications you have set on the microscope, the same magnification should be set here. So when you're playing the camera, you can see the video here, and when we click this snap button, it will snap the image and an icon will be shown on this right window. Right now what we do is we also have an option to load an image. So we will load an image. Let's say we will load this image. So if you are capturing the image, it will be something like this. When you click on the snap button, the image will be snapped and an icon will come here. You will get a message that image captured successfully. Now you click on this image, it will open the image on the main screen. If you click on this clear button, it will clear everything. If you click again on the icon, it will show you. Now if you see below, see, when we defined the component template, these were the parameters that you selected for this join template. If you remember, we also set the expected values and tolerances while defining the component template, and they will be loaded automatically here. If you want to make any changes, you can make the changes here. If you have not set any master, let's say root penetration, let's say so you can set the expected values and tolerances at the master level, and also, or you can set it during the runtime. Also, if there are any changes to these values, you can change it at this point. Now we will do the measurement. If you see, you have given software has given a lot of features here on tools like creating a line, creating a circle, creating an arc, curve, closed curve, angle, points. The buttons that are below are used for profile measurements, are not applicable for welding measurement, which we will not be discussing here. The pointer is for changing the mode. For example, if you are clicking on the line button, it will ask for a color. With what color you want to create a line. So these tools you use to define the boundaries, and after defining the boundaries, you will measure the distance between the boundaries. Select the boundaries and do the measurements here, which you will see in the for the rest of the video. You can select a color here, whatever color. You can select any color. If you see here, my mode is line. Now whenever I am clicking on this screen, the system is assuming that I am going to create a line. If I have finished my definitions, I can click on this pointer button. This means my mode is cancelled. Now if I click on my screen, it doesn't do anything. If I'm clicking back again, I'm again moving line mode. If you have noticed, it hasn't asked the color this time because in the previous step we already set the color. So by default, if you have set the color, selected any specific color, it will not ask again. But you have an option to change it. For example, there is a more option here. There are more options. Color. You can set the color to some other values, blue or red or anything. I'm selecting red here so that it is more visible. But we can change the color at any point using this option. Now this will give you a zoom window. If I click on this button, my zoom window will open. Zoom window, I can do by magnification. What it will do is it will magnify my mouse window. So wherever my mouse is moving, there's a red dot in this small window is my mouse point. It will show a magnified view so that I can select my boundaries accurately. Now I'm defining a boundary here. This is my sheet boundary. I'm creating a boundary here. Created a line. Similarly, I can create a line here. This is my next boundary. If you see, there are two ways to create this boundary. Either you can create a point and click here, but you don't have any idea where this line is because this is hidden because of this weld bead. So what will I do? I will click on pointer. My mode is cancelled. I right click on this option. I delete it. What will I do is I'll create a line here. A line that is parallel to this point. Now I cancel the mode and I will click and drag this line to this point because the reason is this part and this part will always parallel. So these are some options that I am showing you so that you will get an idea about the features and options that you are going to have. System then will automatically find out the intersection points. Now if you see, this is the weld bead, my profile of the weld bead, my penetration here, and this is my penetration on this point. So what will I do? I will create a curve here. I can, now I'm in the curve mode. So I will just click through the boundary. I right click and end the curve. I can also create a point. Now the advantage with the curve is that I can always get the distance, the smallest or largest distance between the line and a curve. System will automatically scan this curve and find the deepest point so that I don't need to automatically select the deepest point to get the penetration. I can optionally also define a point. We will do that option for the second penetration. I will select a point tool. So I defining a point. I am looking at this profile and selecting a point which I feel is the deepest point for my penetration. Now I will select the boundaries for my root penetration. Root penetration is this point, the midpoint, the 45-degree angle midpoint between this and this. This is the throat, the peak point. Similarly, my leg boundaries from this intersection to where this bead ends is my leg distances. So I'm selecting the boundaries there. So now I have finished defining my boundaries. So I'm nullifying my mode. So I'm not in any mode. I don't need this. Now I have defined my boundaries. If you see here, system already give you the date, at what date and time you have captured this image. Now I am going to measure. I click on compute. I get this menu option. I'll say distance between L1 and R1. So I select L1. I select U1, sorry, the row. And I will tell the longest distance because I want to get the deepest point here. So system will scan it and give you the deepest point here. If you see, you click and drag these points here. If you see, it is 1.637, but my expected value is 1. My tolerance is, so my expected range is 0.8 to 1.2, whereas my actual value is outside that, so it give me a fail condition. But if you see, I'm just manipulating it so that you will get an idea about how it works. Now it is pass. When I put the expected value is 1.5, so my range is 1.3 to 1.7. It is within the range, so it is pass. I'm entering my sheet thickness, let's say it's 3 mm. So system automatically calculated the percentage penetration, which is within my range, so I got a pass. Similarly for depth 2, it is between L2 and P1. So it is pass. Thickness, let's say, enter again, let's say 3 mm. But now it is 34% below my range. So, but if I am changing it, similarly, you can measure all the parameters. You can basically, you are doing selecting the compute, selecting the boundaries, and doing the measurements. There is also another option to do the measurement without any boundaries. That is direct method. For example, I'm just trying to giving a demonstration. Let's say I'm measuring the, I'm using direct method. I click on direct method. If I click between 2 points, it will show the values. It will populate it here. See if it will populate it here. So if I clearing it, it will get deleted. If I click on direct means, I click on the start point, I click on end point, it will give you the distance between that. You don't need to define any boundaries. So you can measure that way also. So once you have completed your measurements, what you do is you will save this work. I am not measuring the rest of the part. To save the component, view edit work detail, you click on that. Now look at this point. Here in the reference, if you see, I have created a generic joint template job 1 and using that to measure all my joints in this component. But at the time of saving, I am telling the system this measurement is for WJ206, which by default it came because we have set that in the master. So again WJ206, motor robo weld machine. If you see from the component template, already my master data came. There are some optional features you can add it, created by or approved by. Any remarks if you want, you can put it. And if you click on the save, work saved. So this will save permanently in the database in the system. So if you look at the images tab, that image is disappeared. You can find that in the works tab. See, if you click on that, it will open again with the image with the boundaries, and this will show you how you did the measurement. This can be recalled anytime, even after 3 months, 6 months, 1 year or 2 year or 5 year. As long as you don't delete this data from the system, this will remain in the system. The advantage is that if you get any non-compliance from your customer and if there's any audit, you can go back to that specific date. If you look here, there is a from and to date. By default, it will be 2 days. Whichever date is, it is. You can always go to any previous date and see the samples you have done measured at that date. So if you have any non-compliance that you have got for, let's say, on March 5th component, you can always go to March 5th and see the samples that you have measured at Marsmith. Open that work and see if there are any issues or any measurement done wrongly. This is the advantage with our system. This is a unique feature of our system where we will keep a record of all your measurements. That means you will have the historical data. If you have the historical data, you can always do some SPC reporting and do some analysis on your data. As well as you can always go back and see if there was any non-compliance or audit comes. You can always go back to that specific date, open the work, open the sample, open the work you have done and see if there were any issues or any mistakes or anything that you need to improve in your process. So since you have saved the work, you can clear it here. So it will remain here. So if you select the sample, what some today, you select the joint today, it will show you the works. See, click on that, it will be open. Now if you want to create a report only for this joint, there are different types of joints, reports. You can create a report at joint level, or you can create a report at a component level, means a report which has the data for all the joints, or a report only for a specific joint. Now if you want to create a report for this, you can click on view edit work details and click on the create report button. This will create a report in PDF format or Excel format, whichever you have set in your master data, which will show the results. In another video, we will show you the different reports and report formats that our Well-Dai system supports.